And here we go. Hey guys, welcome to Money Farming YouTube channel. And in this video, we're gonna be continuing from our last part. So we read the article till this point, right? So temporal shift till here. Okay, so let's continue and let's continue reading. Okay, now, um, all right. So FreqAI feature expanding the base feature set with a temporal shift um, is done by setting an integer for the number of requested shifts. So include shifted candles for it's good. So note this temporal expansion is a good tactic for decision trees where the temporal aspect of the time series is otherwise lost. However, in other cases, such as for autoregressive methods, the temporal nature of the feature is inherent to the model training, inferencing, and is decided by dataset creation and batch sizing. So, is what they are saying is it's very much like autoregressive model, like ARIMA and all this stuff. No, um, so they use this temporal shift data a lot, meaning so suppose if this is your time series, this is your data, and you want to predict what's going to happen next here, or is it going to be here, here, here. So they take all this data into account. So this is your first temporal shift, or no, yeah, this is your first temporal shift, second, third, fourth. So you can basically align them in this uh, column around here and tell them that okay, this is first temporal shift, second, third, fourth. So in this way you can build feature of showing that all these data points are you know um, can be placed around here, and we can make inference from the data. Basically we can make sense from the data that they are um, see they have this like properties of temporal aspect. Okay, now let's move on. So traders also tend to watch multiple temporal resolutions, which is like time frames, to evaluate both micro and macro movements. Thus it makes sense to replace all base indicators for a variety of time frames. Okay, so that the parameter space includes the relationship between micro and macro moments. This is very important. What they're talking about, like instead of just like one or four temporal shifts, why not just use like time frame? So if we are trading with 3 minutes time frame, we can include 5 minute time frame, 15 minute time frame, 1 hour time frame. So this would be like two temporal shift. This would be like 5 temporal shift, because 3 times 5 is 15, right? And so on. So you can see that what we're doing, basically what they're saying now is like, see, suppose this is 3 minutes candle. Okay, so if you take the 15 minutes candle, so this will be your close, this would be your open, and then you have 15 minutes candle like this. um, so, so 15-minute candles like this, big candle, instead of this small candles of 13 minutes. Okay, now we are capturing more data from this perspective, like this is open, this is closed, this is high, this is low, and we have added all these 3 minutes time frame candles, and we are just representing with 15 minutes candles. So that's basically capturing your micro and macro moments as well. So there's that. Okay, um yeah, so let's move on. um okay, so FreqAI feature, let's note something. Expanding the base feature set for multiple time frames is done by providing a list of time frames, including time frames like 5 minutes, 15 minutes, 4 hour, 1 day. Okay, so how we can verify this is I actually like to do it, live. So I'm gonna show you what what they mean by that. Okay, um, so go to FreqTrade and go to FreqAI, and on the configuration you can see this, right? See, include time frames. So feature parameters include time frames 5 minutes, 15 minutes, 4 hour, and include correlated pair list, Ethereum, Link, BNB, USD. So this is your shifted candles too, and yeah, and you can see this in their GitHub as well. So when I go to GitHub, go to FreqTrade, go to, hang on, configuration. No, it's not that. It's actually config examples, and go to FreqAI examples, and here you'll see this, right? So um, so this include time frames. So it's going to include 3 minutes, 15 minutes, 1 hour time frame data, and here include correlated pair list is Bitcoin and Ethereum, and here include shifted candles is 2. So that's that's so far there what we learned there. Okay, now let's continue. Okay, so traders also like to, sorry, no problem. So traders also like to vary the look back window. Okay, look back window on their indicators. So these windows are often quite personal, and traders become tuned into their preferred look back windows. So some, what they're talking, someone use like 9 SMA or EMA, you know, 10, 13, just like someone just for the sake of it, Fibonacci uh, trading, what they do is like they follow the sequence. So what's the sequence? 1 1 2 3 5 8 13. So when you combine this is 21. So people use 8 13 21 uh, as their like EMA values, and they make decision out of it. So that's what the preference, what they're talking about. So that's your EMA period. Okay, now so that's their preferred look back window. So this means the feature set should also include a varied look back period such as SMA 10, SMA 20, and SMA 30 candles. By including these look back periods, the model gains a sense of this additional dimension that traders use before clicking buy or sell. All right. So FreqAI feature expanding the base feature set for multiple look back windows is done by providing a list of window sizes, which is this and this. And I think we saw that. Let me show it to you again. And I'm gonna put it there. Um, Vertical, and let's put it around here. Okay. So what's the shortcut there? I wonder. Select pan. So if I click P, did I select pan? No. System hotkeys. Activate this. Yeah, you know what? I'm just gonna do uh, L test. Alt S got the pen, and then this mouse. Select highlighter, select arrow, um, select line. What? New page is N. Delete page, right, left. Select highlighter H. Okay. Activate Alt Shift A. We select Alt S. No, no, no. Alt A. Alt A. Toolbar. Recording, colors, setting. Keep separate pages. So here eraser, cursor. So cursor is escape, okay? So here escape, now cursor, right? And if I want to select pen, S, H is highlighter. See, new page is new page, and Control S, select is pen. Okay, I think we got that. So let's go here. Yeah, configuration here. So activate it and S, and here you see this indicator period candles. So this is what they're talking about. So they are actually using it for SMA 10 and SMA 20. Okay. Now what AI can learn from this is, so if this is SMA 10 and this is SMA 20, then AI can learn the so at certain point there will be difference between the value. So it might learn that, okay, when 10 is about 20, then it's a like uptrend or something, the basic human emotion that we know, and basically it will inform that decision. So yeah, so let's go back. Okay, so we got that. Now these are some of the transformations that we may consider when building our feature set. Okay, but it should be noted that these transformations start to enlarge the data set in an exponential manner, because what we are doing here no is like we are uh, so basically uh, in every step, as you add new column of data there, you're basically increasing the dimensionality. That's what we call the curse of dimensionality, because once you have like a lot of data, and then your model have a hard time to predicting it. Not lot of data in a sense, but like lot of column, uh, because the size of matrix it keeps increasing. So if it's like suppose we have 1,000 rows, and now this can be like variable, column value ci. Now this can be like whatever feature engineering we do, it can be up to like more than 1,000. I have like built some feature engineering like around 2,000, 3,000 something columns. So with XGBoost it really works good, XGBoost. But I can't say the same for deep learning model. um, Although it is, there's exception with transformer model, transformer based architecture. um, and so we're gonna be like working on liquid neural network later on, which has like a lot of less parameter. So that's actually like good for optimization as well. So yeah. All right, so let's continue. Okay, so these are some of the transformation that we may consider when building our feature set, but it should be noted that these transformations start to enlarge the data set in an exponential manner. For example, if we want 3 look back periods for each of 3 time frames, and we want the past 3 candles for each of those, the total feature set becomes, so we want this is what we want. Okay, so we want um, so 3 look back periods, that's your 3, for each of 3 time frames, that's your 3, and then we want past 3 candles for each of those, which is 3. So all that turned out to be 27. Now this is what we call being exponential. So this actually is your exponential function. So 3 to the power 3 is 27. Now so this can be changed, x to the power y, uh, that's your exponential function. And like exponential have characteristics of being like exploding. So like it starts from here, like boom. So this is your curve for y equals to e to the power x, but like this is your exponential constant. But like once you replace that, you can understand that it's very like, as you increase the value of x, it gets very big, the value of y, and that's why your dimensionality would like increase. So continuing, um, so 27 features based on a single indicator selected during the first step of feature design. If the feature set includes 20 indicators, the total feature set contains would be 540. you know just imagine that, man, that's a lot of feature. So yeah, we're gonna be, so that's why like we'll be what we're gonna be doing is like logical feature engineering. I actually call all of it logical, because most of the time in trading now is like even people are thinking they are doing logical shit, it doesn't make sense. Okay, now once you do the logical feature engineering, then you are basically thinking from the domain expert perspective. Domain expert, yeah. So so basically, suppose you have this data of yours, you basically pass it to a domain expert. Okay, now this guy is a domain expert. Okay, uh, so you pass it to him. All right, now it does its own magic of domain experts. Okay, remember that there's a domain expert, in this case a trader. Okay, a trader. And then you basically have less you basically have optimized feature set for your problems to be solved. Okay, that's what we're going to be doing. So yeah, I think you guys gonna like that one too, um, because this is the way we are trying to solve the problem of trading. Okay, so first, human trading, looking the things from that perspective. Then we move on to, so like to build the foundation, this is what I mean, to build the foundation. Okay, so human trading, then we move on to logical algorithmic trading, and then finally we're going to combine both these, and we build logical AI trading algorithms. Okay, so you see this actually like completes the circle. you know so um, you have this, and then so basically at the end of the day, what AI is gonna do now is gonna learn from this uh, and this. So it has the combined base knowledge of all both of this, and it makes better decision now, right? So that's what we want to do, and that's where the domain expertise comes from. Okay, so that's our like domain expertise there. So yeah, we're gonna be doing a lot of streams with this one. So for instance, here we can add like new indicators, new indicators that we have developed. What I mean by that, like last couple of streams, what we did, we built daily pivot points. We can add that as a indicator. Okay, for support and resistance. What we have now, we also built like um, candle sentiment analysis, candle sentiment and candlestick properties. Uh, so that can be added as as your feature set. What else we did? um, we did like a trend following system with EMA 3 system that we talked about. We had ATR, stop loss, like a dynamic ATR for risk management. That's your feature. What else? Candlestick patterns, that's your feature. Okay, but this candlestick patterns, what I want to do with this is like make it like categorical. Okay, so what I mean by that is like, so this doji candle, hammer, spinning top, um, inverted hammer, um, you know gravestone doji, all this stuff. And then like you basically, instead of like having value for it, it's just like you write doji hammer spinning top inverted hammer. So once you pass that to AI model, no, it actually like understands what doji means, what hammer means, what spinning top, what inverted hammer means. So we're going to be doing it in like transformer model. Okay. And we're going to map the attention map and look at it like where it is activating in the attention map. Okay, so moving on. So it is common for traders to also keep informative assets. Okay, so informative assets, here we're going to talk about like Bitcoin, the large cap coin. So in mind, so it is common for traders to keep informative assets in mind when entering or exiting a trade on an asset. So informative assets are usually market leaders. See, this is what I was talking about. Bitcoin alone is half of the market cap of cryptocurrency. The whole cryptocurrency, half of whole market cap. 50% of market cap is Bitcoin only. Others are altcoins, where leaders are Ethereum. Then you have Chainlink. All this cool stuff, right? So you can add it as like your informative pairs feature, um, which is actually giving, it is informing that these are the leaders. Okay, these are the leaders, and you should pay much attention to what they have to say. All right. um, so I think I'm gonna save this PDF and share it to you guys on the Discord. Okay, so go there, save all pages, and I'm gonna go to um, content creation, money farming, and gonna put it the name, AI AI trading with FreqAI. Okay, And also we can save the project too. So AI trading with FreqAI. All right, so let's get it going. Yeah. Now, so informative assets are usually market leaders that tend to exert a strong influence on market movements. For example, a cryptocurrency trader would perform poorly if they did not have the health of Bitcoin in mind at all times when entering and exiting trades. Likewise, the S&P 500 plays a similar role in traditional equity markets. Thus, a good feature set should include informative asset data for all the base indicators, as well as all the transformations discussed above. Further, traders typically use more than a single informative asset. Adding informative assets expands the feature set even more. If we include two informative assets in our feature set, the base feature set of 20 indicators has now grown to 1620 in total. Just imagine that, you know, that's a lot, right? I mean, so see this, right? You multiply it with three. For three informative pair, we have already like Ethereum, Bitcoin, and then the suppose we want to uh, do it for like link the link USDT. So combining that, so this 12, 1, 16. So this much feature we got. Okay, this much columns we have in our like data frame. Okay, around 1620 columns. All right, and row is like you can decide what the row can be. So imagine, you know, metrics of that much, you know, like in deep learning there's much more, but still the computation, you need a lot of computation power. That's what I mean. That's why we use GPU, and we're gonna use a lot of GPU here in this series. So yeah, in FreqAI. So FreqAI feature including informative assets in the feature set is simply done by providing a list of assets, which is including correlated pair list, which is Bitcoin, USDT, and Ethereum. So in order to show you here, um, um, yep. So here, see this one. That's your informative correlated pairs, Bitcoin and Ethereum. All right. So let's go on and continue. Yeah. So um, okay. Hmm. So time series, time frames, temporal shifts, look back windows, and informative assets are only a few possible components to add to the feature set. It is only the imagination of the feature set engineer that is the limit. See, that is very important. I want you to pay much attention to it. Okay. So see, it is only the imagination of the feature set engineer that is the limit. All right. Now that's why in this channel now we're gonna do lot of feature engineering. What is feature engineering? Feature engineering is just technical analysis. If you know technical analysis, you know feature engineering. Okay. Feature set engineering, trading, related to trading. So yeah. So you know, it's like what I like to say is like so um so if you know about um, technical analysis, you basically know you are basically a feature set engineer. Okay. All right. Now you can understand that like this is where we have to do a lot of work, and with technical analysis we also have to be like AI engineer as well. um, AI engineer, what I mean by that is like you should be able to do DevOps, um, like deep learning model, build a deep learning model or machine learning model, you know, deploy them and then make prediction with it. So you know, it's like QA, quality assurance, and then you have this feedback loop that goes till that. And when you expand it to this, then you have your FreqAI, um, that actually does most of the work and lets us focus on only this one, and we don't have to worry much about deep learning, DevOps, QA, just technical analysis. Okay, so that's the good part of FreqAI is. Okay, so you know, that's why I like FreqAI a lot. You know, it's a really good tool to do uh, a like build machine learning trading algorithms. Okay, so now we're gonna continue here, and let's take the new page there, and I think also save it as well. All files, wait, what? Oh yeah, save all pages. So yep, just replace it. Yeah, so now we are it up to data processing now. Okay. Okay, someone is asking question. Let me see. Um, Hello, sir. Hi. Can I have any contact information from you? Um, yeah, for sure. We are in Discord channel right now, but if you want to contact me, this is my email ID. Okay. Um, yeah. So you can contact me here on this mail, or our Discord server is the way to go. Is is you know, so here, go to Discord channel, and then so here I'm gonna, I think I have to put it in my video. It's some kind of like overlay or something. I have to do it. uh, Invite link is this. Okay, all right, so yep, let's continue, guys. So we are with data pre-processing. Okay, and also, guys, let me know if you have any questions. Okay, I think it would be best that way, um, you know, we ask questions and all this stuff. So if you have any question, no, let me know. It's like, because I don't know how much machine learning AI you guys know. So you know, if you don't understand some concept, please do let me know. All right, so I think I'm gonna overlay the chat here, and then yeah, okay. Let's continue. um so data pre-processing. Okay, now we actually did the feature set. We got to know about what is feature set, this and that, from all the article. This article is written by the way, is written by the guys who wrote the code for FreqAI. Okay, so take it seriously. All right. I don't think you might have read this article. Let me know if you guys have read it already. What do you guys did you have you guys read it already? um um Yeah, I'm gonna keep this channel here docked like that. And yeah, so yeah, let's continue. And we are into data pre-processing. Okay. I did. Yeah, so Philip did. So yeah, kudos to you, bro. Yeah, it's really good article, you know. And once you analyze step by step, then basically like it makes sense that okay, why they did this thing, why they would include this. You know, see, feature parameters, we talked about this, this, Now later on they're gonna talk about this and all this stuff, all right, which is very very important, all right. Like just think about it, guys. Okay. um okay, so yeah, I think so Philip is saying is still trying to wrap his um, head around to it, because he's currently doing a strategy out of a quick adapter 3. Yeah. So and trying to add confluence from BTC dominance, open interest and stuff. Try with what is called fear and greed index. It actually works quite well with it, with that feature as well. So yeah, we're gonna be doing it in our channel anyway. Um, so yeah. so let's see. I want to dock it there. Okay. The Discord link not working. Okay, why? Invite people. I did copy it, right? Edit invite link. So generate new link. So this is the new link. Uh, okay. Um, hmm. So let's continue. So data pre-processing. Okay, now we are moving to the meat part of it. Um, Data pre-processing. All right. So data set pre-processing is equally important to base feature set design. Okay, these two things are equally uh, important. Why is it saying it's already expired? I don't understand. What it says it's already expired. I don't understand. It's like a lot of people joined here. So um, invite friends to money farming general, or send a server invite link to a friend. Can you guys check if it works or not? So I'm just gonna like show it to you here. So I go there and you can see here it's working for me. So it's just like you tell your name, something like say John Doe, and then they're gonna ask you for some, like, so I'm just gonna say outdoor area. Okay, what is outdoor area? Here, this one, this one, this one. What? Outdoor area, man, come on. Okay, that's not outdoor, technically speaking. Okay, so see, now it actually got me there. So yeah, it's actually working. Yeah. Yeah, I just did. It's working, bro. So I don't know what's the problem is there. Okay, so let's continue. And yeah. So data set pre-processing is easily important to base feature set design. It cannot be ignored. Okay, so this is very important, guys. Um, yeah, for sure. Send me on the text, and I can add you on the channel for sure. Um, so this is the emphasis, guys, that it can't be avoided. Okay, I want you guys to understand this. All right, it cannot be ignored. Data pre-processing. Okay, it's very very important. All right, now. So this is another piece of the model design process where we can inject creativity into the model. Okay, see, trading is a creative process. Okay, all the people who are making money, like thousands and thousands of dollars every fucking day, they are creative. That's why they are making money. All right. So So this is another piece of the model design process where we can inject creativity into the model. Now, however, the basis of the data set pre-processing is not dependent on human emotion. Okay, this is very important. All right. Now, instead, it is dependent on maintaining statistical control over the data set. So let me actually like make it easy for you guys to understand. Okay, you see this chart, you see this figure, right? Figure 5 says pre-processing steps to ensure a statistically robust feature set. Now what they are doing, they are removing the NaN values. So you see all this question mark value. Hang on, I'm gonna zoom in and then show it to you guys. So I got that. So here you see all these features. See feature 1, feature 2, feature 3, feature 4 up to feature 10, and you have NaN values. Okay, so once you remove that NaN value, see your dimensionality got reduced, as well as now you have clean data set. Okay, clean data set. Back in the day, I still we used to call it data wrangling, if you guys remember data wrangling. So yeah, now once we do that, it's like we did this. So feature scaling is like, now it's like it's there. Suppose it's like around the it's 100 something. So it now we have to do scaling, which is like uh, normalization, so that we keep the value between 0 to 1 or -1 to 1. um, you know and so all the data would be rescaled to this. All right, now after that we can do outlier detection, where as we have this swing, these flash crashes. I mean, that's very important, flash crashes. um, and very outlier detection is like where we detect this outlier and then we basically remove it for the better testing of the model. All right, so this is what your data pre-processing step is. Okay, so this is what your data pre-processing step is. All this stuff, data pre-processing or data cleaning, what you want to call it, or data cleaning. Okay, now we got that. Let's move on. Let's move on to, so Anthony is saying, hey man, love what you do, great work. Thanks, bro. um yeah, we're gonna be doing a lot of cool stuff in this channel for sure. So let's continue. um Okay, so here for illustrative purposes, we take our feature set from the previous section, which is which comprises of 620 columns. You remember, you got 540 for each of the coin pair, and as we added Bitcoin and Ethereum, our dimensionality got increased, and we multiplied it with 3, and that's how we got this number. um, this, right? So this is also very important, guys. Like, you should you should be able to do the calculation. Okay, I mean, I'm not saying that like you should know about mathematics of all this, what's going on underneath the hood. That's actually comes in the deep learning, but like you should have basic understanding of what the heck we are doing. Where is this number is coming from. But like anyways, like even if you don't know that, like you should be really good at feature set engineering. Okay, which we're going to be doing a lot of it. So for instance, like if I show you right now, just like right now from the channel, you can do a lot of feature engineering. So um, okay, so here you see um, so we build this C converting trading indicator into Python. So this is your this is your another feature, okay? Another feature right there, okay? See, this one is strategy development. When you guys go and look into it, no, it's like then you'll understand that like we have already talked a lot about feature set. Like, see, for this, in this one you can use this one feature, pivot points. This is one of my favorite features. And yeah, guys, so you know take a look into it, and also we're going to be doing a lot of it, so don't worry. um I'm going to be yeah, I'm going to be doing a lot of feature engineering as well. So let's continue. And it's saying that each column represents one of the feature sets, right, that we already talked about. Each row of this data set is a single data point representing the feature set at a single moment in time. Okay. Now, typically the time of the candle close in traditional assets and cryptocurrency. So that's the candle close that we want to. So like time of the candle close meanings like if you have suppose 15 minutes candle. So what you have is like so this, right? Now you have open, high, low, and close. And if it's a green candle, then you basically have this, right? This configuration. So if I put it in data, no. Um, so suppose if I put it on data, it will look like so open, high, low, close, and then volume, and then you can expand the data set here. Now what they're talking about, no, they're talking about this row. All right. Now here you might have some value x1, x2, x3, x4, and the time is like this. Okay, it's time dependent. So it's like if this starts at 00, this will be 00 15 minutes, this will be 00 30 minutes, this will be 00 45 minutes. Like, you can see the pattern there, right? So this is like unique. See what they're talking about. Each row of this data set is a single data point representing the feature set at a single moment in time. So at a single moment in time, it's representing that feature. So if I want to look at what was the open price for this particular time, this was the open price. Okay, this was the high price, this was the low, this was the close, and this was the volume. So you know so machine learning model actually looks at the row for that particular point. So suppose if I want to make prediction for the next 1 hour, right? um, Now I have to pass all this data back, you know and it will make prediction from involving all those data, right? So yeah, so this is what I mean by that. This is actually what they mean by that. Okay, now let's continue. And so okay, yeah, so dealing with missing data. The first step of pre-processing this data set is to identify the non-existing data entries and remove them. Just remove them. Okay, as we see in the example there, these are referred to as NANs. Value, which basically means not a number. Okay, NAN means not a number, or just like it's nothing. Basically, in data science, and their mismanagement is a typical pitfalls to early machine learning enthusiasts. NANs originate from missing data points. These missing data points may be holes, okay, in the data set due to difficulty collecting data by the original source. But more commonly in the market analytics, NANs originate from the look back period associated with the majority of market indicators. Okay, I hope you guys understand this. Like, see what they're saying. So if I do SMA 30 of close, what I'm saying is like I want last 30 close price to make one SMA. So I'll get last 30 close price and from that I'll get 1. What I'm gonna do, first 2, and then just gonna sum it till 30, and then divide it by 30. Okay, that's your like average price. Okay, so simple moving average. All right, now what it's doing, like once you do that, no, it's like all the previous 29 row would be an empty nans. Okay, and then here only you would have data, and from here then you would like basically do the will get the data. So this nans, no, it's like it's nothing. You should remove that or just backward fill it, you know, b fill, you guys remember that b fill, so that like you don't have to drop that data. Okay, it's the initial condition thing that I'm gonna teach you guys later on. So uh, so we got that, and so NaN originate from the missing data points. This missing data points may be holes in the data set due to the difficulty collecting data by the original source. But more commonly in market analytics, NaNs originate from the lookback period associated with the majority of market indicators. For example, the SMA 1 hour window 30 computes SMA on 1 hour candles using statistical quantities associated with the previous 30 candles. Thus, the feature requires 30 hours of closing price data points before the SMA 1 hour window 30 has sufficient data. See, this is what we were talking about, right? So until that point, the data set is filled with NaNs. These NaNs must be properly dealt with, or else the parameter space will be incorrectly defined, resulting in poor model performance. I mean, just think about for yourself, guys. Like, if you don't really know what that data is, like how you're gonna make sense out of it. Okay, that's why, you know, in machine learning we do really see, in the first thing they said that like it's equally important. Okay, see, this is, it cannot be ignored, they are equally important. Okay, so yeah, now we got that. So until that point, the data set is filled with NaNs. These NaNs must be properly dealt with, or else the parameter space will be incorrectly defined, resulting in poor model performance. And trust me, we don't want that. All right. So we want our model to perform really, really well. I mean, guys, just imagine 3 years ago, this library didn't existed. Okay, FreqAI, and very like new deep learning models, machine learning models, optimized version of it, they are doing all the heavy work. Okay, what we have to do is like we have to become domain expert in it. Okay, like machine can't really do everything, but what we can do is like, just from prompt engineering perspective. Okay, ChatGPT came, this job didn't exist called prompt engineering. Now people are getting paid more than 100 grand a year to for becoming a prompt engineer. So, you know, so basically the point that I'm telling, you know, is like we do need human in the loop for as a domain expert, so that whatever data we give it to model, no, it should be good data. Okay, that's what we're it's what that's what they're trying to say basically. So many early machine learning enthusiasts believe that these NaNs can be easily searched and replaced with zero, or some other quantity that has no apparent relevance. This is a mistake. Inserting zeros in place of NaNs for our SMA would bias. See, you would bias the model. This is this is gonna be the real challenge that we're gonna face. Bias. Okay. This is what we have to do. You know, it's like in algorithmic trading, what we have look ahead bias. Okay, look ahead bias. Okay, now here we have all sorts of bias, man. Like literally, once you look at the list of biases, no, you would be amazed that like, whoa, what the fuck is going on? How we came here? Like, you know, how much bias is there? Um, Okay, so Aras is asking, should I spend time creating a profitable trading strategy or spend time with FreqAI? I would say both. Let me tell you why. Let me explain it to you why. Okay. Um, so last in our last video, what I did, what we I actually live streamed this one, right? So I'm actually running this second series, first series on on crypto trading. I call it breaking good. Okay, now what I'm teaching here now is like I'm teaching you guys the real way to make money. So I talked about this indicator that we're gonna use, and I'll also share the code for it as well. I don't know, it's somewhere around here. um, okay, so see this one, right? So this indicator, custom trading integer indicator, I actually shared it. You guys can look into it, and then just add it in your Pine script, and then yeah. The thing is, like, see, this is what we are doing. So I actually deployed this live on the channel, like after doing the analysis. Okay, and so this, okay, at that time, so this was a deployment, and see, within just the day, it has like made $24 profit for us with $500 investment. And the best part is like it's doing risk management really, really well. Now the thing that you are asking now is like, should I spend time creating a profitable trading strategy, or um, or spend time with FreqAI? So the answer for this is like, do you know about trading? Okay. Now, why I'm telling you is like, see, you can automate this stuff like really, really fucking well. Like, I mean, I've done it before. So what I did, I built one reinforcement learning algorithm. We were using what was it? It's like Q network, and then I also used yeah, A2C something. You guys ringing any bells? A2C, A3C model, all this stuff. And what reinforcement learning does know is like, it automates every single fucking thing. What I mean by that is like, so in trading, what you have, hang on, I'm going to explain it to you in the blackboard. Um, so in trading, what you have now is like reinforcement learning. So this is gonna be the mother of all trading strategy. Okay, reinforcement learning. You don't have to do anything with it. It will figure out everything for you. Okay, so like entry price, entry point, yeah, it will figure it out on its own. Okay, stop loss, where to put stop loss, yeah, it will figure it out. Where to put take profit, it will figure it out. Or if you want partial exits, we can do that too. Partial exits. And what else, like, time, how much time you want to stay in, how much time. Or basically what I mean is like time dependent exits. Okay, time dependent exits. I hate it when my pen doesn't work. Time dependent exits. So um it's like it will do everything for you. We don't have to, we just have to do the, like, handle the machine learning, which is FreqAI. But the thing is like it requires a lot of power, GPU resources and all. So yeah, the thing is like this is actually a journey, like, it's like, we do we learn about trading as a human, then we do feature engineering with technical analysis, which is algorithmic trading, and then we combine that to build AI model. Okay, so my only suggestion is like, if you don't know about those two stuff, uh, basics of trading and feature engineering, then you should really pay attention to, I mean, nowadays, like, you don't really have to search for it, like, everything is in my channel. So if you just want to take the code, no, you can take it from there as well, and it's very easy. So yeah. Moving on. So we were here. Um, so okay, so we were talking about this. So this would bias the model to associate a single outlier value 0 to price action, right? So um, so see, we have to focus on that one to remove the bias. Okay. So other data science students may think more critically about this and decide to replace NANs with a statistically quantity of the column, such as the mean or median, right? This is a better approach, but these data science students should consider how there are other features associated with same data points, right? And the combination of the median from feature A with a real value in feature B is an artificial combination that never occurred in reality. So what it means, what they are saying is like they are talking about synthetic data um, generation with the statistical model, uh, statistical model. So we again come back to the statistics where you have your mean, it's like your mean, and then you have standard deviation. Okay. And like around 68% of the data is represented with first standard deviation. So that's what they are actually talking about, that like if you do it, no, it's like use the statistical model there. But anyway, I think what what we should do now is like whether we use this or just like let it like leave it with the um, you know uh, what's the word I'm looking for, leave it with the um yeah, backwards feeling, yeah. uh, yeah, so backward feeling is like you basically so what I mean by that, no, so suppose so this is your closing price, hang on. So this is your closing price, or candle, and once you overlay the EMNO is like, so you have candlestick here as well, data, but you're starting the data only for this one, from this one on SMA. So um, it's acting weird. So here your starting point is this for the SMA. Now you don't have data points for this one, so what you do, just like take from there, just set all the value to that last value. That's what we call backward filling. Backward fill, this is very important, so you should guys take a note of it, something, you know. So this is our like initial condition, to be honest, or if you do it with a statistical model, it's not always right, so just keep that in mind. Okay. All right, so let's continue. um yeah, so what they are saying now is like feature A with a real value in feature B is an artificial combination that never occurred in reality. So if we feed that unrealistic data to the model, how can we expect it to make realistic predictions? Right? I mean, that's why we have to do lot of, we have to focus more on data uh, than model, because if you are working with FreqAI for a long time, then you know that like basically we use the same model for pretty much every feature engineering set that we have. Okay, the model stays the same. It's like there's the only thing that we are changing is feature and hyperparameter optimization. It's like, yeah, that's the second thing. So yeah, you know so let's continue. So So the only statistical consistent and realistic way to handle NAN is to remove the entire data point, the full row, including the other existing feature data. All right. So they are saying the only statistically correct way, consistent and realistic way. So they are right, with the statistically, but like you should also um, imagine that like once you have like thousands and thousands of rows, uh, even if you are like even if you get trim of like 50 rows, you still have 950 rows to make predictions with, right? So we're not losing that much if we cut that off, and if we like backward fill it, then then basically it won't have that much effect, to be honest. So we're gonna do it both way and see how it goes, you know let's continue. So after this we're just gonna get into the XGBoost and like deploying it on machine, doing it practically. So I actually got the machine rolling, so I'll show you. I got Tesla T4, but I have like RTX 3070 in my computer, so I think I'll probably use my laptop for training. But like I want to show you guys, uh, so to tell me if you guys use it in your computer or deploy it in cloud. um, because we do need GPU for that. So this, see, we got like GPU, see, NVIDIA Tesla 4 T4, 16 gigs RAM memory, GPU memory, and yeah, and it's like virtual. Um, yeah, okay. So we're gonna be doing that later on. So let's continue. Let me see how much we got there. I think we have a lot of left. So I think I'm gonna stop the video right here. I want to keep the live stream like 1 hour, you know. So yeah, so we talked about dealing with this. We read this. So let's read this and then we go to the feature scaling in the next video. Okay. So the astute reader would recognize that the number of data points available in our indicator dataset is strictly limited by the indicator at the highest time frame using the longest look back window. Okay. So despite the fact that our data set is mostly filled by the shorter indicators relying on much less time, the data corresponding to time points where the longer time frame indicators are NAN must be sacrificed to satisfy strict statistical assumption, okay, about the data. This sacrifice is not in vain. They're really getting into fantasy. It enforces a clear picture of the parameter space. Yep, it does. Yeah, I think I'm gonna play game after this and do live stream as well. Yeah. Have you guys played Starfield? It's really good game. It took them 25 years to build that fucking game, man. It's just like, yeah. So FreqAI feature is like FreqAI automates this entire process so that the user does not need to worry about how much data is needed or where the data should come from. See, this is why I like FreqAI. Okay. So for example, if user asks for 1 full month of training data, provided a custom set of indicators, FreqAI will identify the longest indicator and preload the data so that there are no time frame included no time frame induced NANs in the entire months of data. Okay, so it actually automates everything, so we don't have to worry about it. But like you should know that this is something that is doing so that in the future, once like I mean, there's already exist a way to synthetically generate data. Okay, synthetic with deep learning and all, and it's very very good. So yeah. Anyway, FreqAI does it automatically, so you know kudos to FreqAI for that. And so today we talked a lot about. I'm gonna share this to the channel here. So today we talked about data pre-processing and all this stuff. Read the article, and so what we did. So let's recap a bit. And so we read that. No, a lot of stuff here. So you guys can look this PDF if you want to understand pictorially, what we talked about. Take it as like guiding, so yeah, it's just for recap. Yeah. All right. So we actually covered a lot there. So in the next video, we're going to be looking at feature scaling, and yeah. So thank you so much for joining the stream, guys. I hope you guys like the video, and let me know if you guys have any comment, question, and queries. And I hope to see you guys in the next video. Please like, subscribe, and hit that bell notification if you haven't done so. And I'll see you guys in the next video. So happy trading.